Good evening, Bearcats. This is 4.8 Applications and Models. We're going to go through several examples to show you how to use your inverse trig functions, your or properties, your Pythagorean theorem, and a combination of SOHCAHTOA to solve some application problems. Of course, usually the hardest thing about applications is setting up your problem, and that's what we'll be spending quite a bit of time on the next couple of days. All right, so first let's take a look at this just triangle here. We are going to solve the right triangle as shown in this figure. I'm going to draw mine blank over here so I have a clean place to write. And this is A, B, and C. All right, it tells me that angle A is 28.4 degrees, and that side B, which would be right here, is 21.6. It wants me to solve for all the unknowns. Well, a couple of things is we know this is 90 degrees, so angle B could be solved by, I'm going to call that big B for the angle. Angle B would be 90 degrees minus the 28.4, or 180 minus 90 minus 28.4. But if 90 already is out of 180, then you would just be taking 28.4 out of 90, and that would give you 61.6. Okay, so that would give you your angle B, so this would be 61.6. All right, next let's solve for A, which would be this side right here. And for little a, which would be the side, I want you to think about what you have. Use the numbers that you were given first in case you make a mistake on one that you find, then you don't, just continue making a mistake. Angle A, side A would be opposite the angle we know. So if we have the angle, that would be the opposite side is A, the adjacent side is 21.6. I believe that would be tangent. So you would say tan 28.4 degrees equals opposite, which is A over 21.6. And to solve for A, I'm just going to cross that out. To solve for A, you would have A equals tan 28.4 times 21.6. And when you do that, you're going to get approximately 11.68. And then finally, we could use Pythagorean theorem, but I really prefer you not to do that, because if you had made a mistake on the 11.68, then your mistake is going to carry through. So I would start over using the things that you have, and we're going to be looking for the hypotenuse. Again, this is our angle that we were given. The side that we were given is adjacent to that angle, and we want to know the hypotenuse. So the side adjacent over hypotenuse would be cosine. And so to find angle, or side C, I should call it, not X, C, okay, to find that C value, you would say cosine 28.4 equals adjacent 21.6 over hypotenuse, which is C. And we would end up solving for C. Let's see if I can sneak that in there. And it would end up being 21.6 over the cosine of 28.4. All right, so you kind of have to think about that. It's a little bit of a puzzle of putting things together, but I always circle or highlight my, let's just even do that. I circle or I highlight the given information, so I constantly are going back to that given information so I don't carry through a mistake that I may have made along the way. All right, let's keep going. The next problem we're going to talk about has no picture for us. We're going to have to set up our picture. We're going to do a lot of that tomorrow in class. This is a safety regulation test that the maximum angle of elevation for a rescue ladder is 66 degrees. It says a fire department's longest ladder is 77 feet. So we've got 77 feet. We've got 66 degrees. Those are key numbers for us. What is the maximum safe rescue height? And we're going to round it to the nearest tenth of a foot. Okay, the first thing I'm going to do is going to draw a right triangle. We know we're doing right triangle, so I'm going to draw a right triangle like I would be in the first quadrant. And then I'm going to label my right angle. And then I'm going to go back and read again. It says a safety regulation states that the maximum angle of elevation for a rescue ladder is 66 feet. So angle of elevation, that would be here. Our theta right here would be max 66 feet. It says a fire department's longest ladder is 77 feet. Well, I'm going to say this is my burning building right here. There's my door to my building, and there's flames coming out of my building. All right, so there's all these flames coming out of my building. And so if that's happening, then what we're going to do, the longest ladder that they have is 77 feet. We want to know what the maximum safety rescue height is. So we want to know how high that ladder runs up our wall. So this is our value that we're looking for. From our given angle, that is opposite, and across the 77 is the hypotenuse. So if opposite and hypotenuse, that is sine. So we would take sine 66 degrees, and it would equal opposite, which is x, over 77. And to solve for x, we would say sine 66 degrees times 77. And I believe when we do that, we're going to get approximately 70.3 feet. You would need to make sure your calculator's in degrees. Tomorrow when you come in, let's make sure we get a yellow calculator if it's not already on your desk for you. And first period, that would be really helpful to go ahead and pick one up for yourself. Everybody needs their own. We'll clear them, and then we're going to make sure we set the mode to degrees when we're wanting degrees, or we're working with degrees. All right, let's go on. All right, this is my last true example. There'll be a few more things for you to do at the end of this video tonight, but this is my last example. These should help you with the examples you do in class tomorrow. This is a swimming pool is 20 meters long and 12 meters wide. So here's the width that's 20 meters long. And 12 meters wide would be the whole width. Oh, no, that's not it. Sorry. Yeah. Sorry. 12 meters wide, you can't see the width of the pool. This is the depth of the pool and the length of the pool. The bottom of the pool is slanted so that the water depth is 1.5 meters at the shallow end and then 5 meters at the deep end. So combined right here, this whole depth is 5 meters. So this would be like the top of your pool. It's kind of a little misleading picture here. As shown in the figure. We want to find the angle of depression of the bottom of the pool. All right, well, they've even shown us where the angle of depression is, so we're looking for that angle. We know this distance, or this height right here, is 3.5. And we want that angle of depression, and we know the length is 20. So from theta, the angle we're trying to find, okay, from that angle, we have the side across from it, and we have the side adjacent to it. So if we have across and adjacent, opposite and adjacent, that would be tangent. So we would say tan theta equals opposite over adjacent. This is a really good problem because we talked about this in class today. We were just solving the equation, or the little examples in class today, that you cannot divide by TAN. You cannot divide by those letters. You have to actually take the inverse to solve for theta. So we would say theta equals inverse tan, or you could say arc tan, whichever one you want to say, of 3.5 over 20. And when you put that in the calculator, you're going to get theta is approximately 9.93 degrees. And that would be your angle of depression. All right. Last couple little things for tonight. Oops. When you get to this page, I'd like for you to push pause, and I'd like for you to read through this very carefully and have these 3 examples in your notes and talk about what they mean, or think through what they mean, each of these degrees and rotations based on what we call bearings. That's really, really important that you do that. And I would also make sure that you copy down the study tip on page 355. I'll look for that in your notes as well. The study tip on page 355, I think it's a little interesting, and we'll discuss the alternative to that particular tip. So I would say pause. I'll be right here waiting for you. Go ahead and pause and write down your information and make sure you get the study tip off of page 355. If you don't have a book at home for some reason, when you come to class tomorrow, right at the beginning before I come around, you want to do that. All right, I'll be right here waiting. All right, well, now that you've gotten all that written down, let's talk about this last problem. We're not going to work through this problem, but I want you to read the problem. I want you to write down the problem in your notes. So go ahead and write the problem down in your notes. You'll want to pause to do that. And I want you to draw a picture, or at least attempt to draw a picture of what this is talking about. You may or may not get it right the first time. That doesn't matter. You know, we talk about that in class all the time. It's about attempting and trying and figuring out what parts you understand and what parts you need clarification on. So when I come around tomorrow, I want to see that you wrote this problem down, and I want to see that you've drawn a picture of what you think the problem is trying to ask you about and the angle you're trying to find and the information in the problem. All right, that's it. I hope you have a great night. We'll talk a little bit more about solving applications and bearings tomorrow. And go Bearcats!